Hello everyone, this is the lecture for section 4.3, logarithmic functions. So in section 4.1, 4.2, we just got comfortable with exponents, right? We just learned as much as we could about the exponential function, right? Now we're going to get into the logarithmic functions, okay? They are completely tied to the exponential, okay? Lots of people get scared of logarithmic functions because it's beginning to sound like things that you don't remember, right? But it's really actually quite simple. People afterwards are like, oh, was that it? Okay. So first of all, what I want to do is I want to define what a logarithmic function is. And before I do that, right, I kind of want to get into why the heck we have logarithmic functions in the first place, right? So if you recall, right, are exponential functions, right, one-to-one. Real big hint. Yes, they are, right? So do they have inverses? Yes, they do. Everything that is one-to-one will have an inverse. Everything that is one-to-one will have an inverse, okay? So now that we have the reason why we have the logarithmic functions, right, they are an inverse to the exponential function, okay? So suppose you had this, right? This is my exponential function, right? The logarithmic function is considered its inverse, and it's written this way, okay? Now, you guys are probably thinking to yourself, how do we write it, right? That right there, okay? So b to the y is equal to x, okay? And it's exactly in that motion. This is actually the same motion that I learned it. This to that power is equal to that. Okay. Another way to do it, right, is this down here. This is what people tend to really like. This right here. This is our boomstick, right? So smiley face, right? And we'll put some fireworks all over the place for it. So, oh, there we go. Whoosh. Woo. This is like a big deal. Okay. Big deal. Big deal. Yeah. Okay. This is the conversion. This one I'm going to highlight it in pink in particular. Let me get rid of that. I'm going to highlight it in pink. This is the key for converting a logarithmic thing into an exponential thing and vice versa. Okay. So if you have the if you have the left-hand side, you can turn it into the right, and if you have the right-hand side, you can turn it into the left, okay? This is going to become real important when we have to solve logarithmic equations, okay? Let me get rid of all the fireworks and smiley faces. I mean, we're doing math here, right? Okay. Okay. Hopefully you guys remember, right, that if you have the domain and range of a particular function, right, the domain and the range flip for the inverse, okay? So I'm going to go ahead and put it over here. So if you remember, right, if you have b to the x, if you have f of x equal b to the x, right, then the domain, right, is going to be negative infinity to infinity, right? And then the range is going to be 0 to infinity, right? So just as a quick refresher, and actually I'm going to move this over a little bit just so I can give myself some room for, okay, if you recall, right, if you had an x and a y, the graph of b to the x is going to look something like that. That's how an exponential function looks like, right? So going back to section 1.7, the domain for the logarithmic function is going to be 0 to infinity, okay? And then the range is going to be negative infinity to infinity. Okay, we're getting somewhere. right? Okay, so now there's something I do need to cover. Okay, can we take the logarithm of a negative number? That's to say this. Can we do log base b of -1? Okay, so the answer to that is actually in our boomstick, the thing that this thing that I have highlighted in pink right here. Okay, so what I'm going to do is this to answer my question. I'm going to do log base b, okay, log base b of -1, and I'm going to call this something. I'm going to call it x, okay? I'm going to actually put it in the correct side because what I want you guys to see is I have the right-hand side of my boomstick. I have the right-hand side of this thing right here. Got it? Okay. So then now I'm going to turn it into my left-hand side. Got it? So I'm going to grab this and I'm going to turn it into the equivalent of the left-hand side. So if you take a look at this, right, this is saying this, right? B to the x is equal to -1, right? Sound good? All right. There's a problem with this. There's a problem with that. So remember how I said, right, at the very beginning, B has to be positive. B has to be positive. Yes? Okay, so think about this really quick, right? This is where our exponent rules from back from section 4.1 are going to come into play. B is positive, and I'm raising it to a power, right? And I want it to be equal to -1. Okay? If B is positive, there is no way in hell I can choose an x, right, that makes this equal to -1. This statement right here, right? Hopefully you guys see this. This statement can't happen. Cannot happen. At all. Okay. So now this brings up a very, very big point. Okay. In the past, in math, right, there were two things that we could not do. Ever, 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 ever. One of them was divide by 0. Right? Okay. The second thing that we couldn't do was we couldn't take the even root of a negative. Right? That one we excused away. Okay, and the way that we excused it away was saying that, oh, if we do get a negative inside of a square root, that automatically means I'm talking about complex numbers. You guys remember that? Okay, this adds a third thing. Okay, this actually says, right, we cannot take the logarithm of a negative number. We cannot take the logarithm of a negative number at all. Ever, ever, ever. Okay, so this ends up being another thing that we cannot do in math. And this will be big once we start graphing stuff. Okay? But for now, what I want to do is sort of get you guys to practice this thing. Get you guys practicing our boomstick. Okay? So, let's scroll down real quick. I'm giving you guys the logarithmic versions, right? I want you to turn them into the appropriate exponential forms. Okay? So, if you guys do this right? If you remember how this goes, this to that power is equal to that, right? So then the appropriate way of writing this is 6 to the 1/2 is equal to the square root of 6. This is completely correct. Got it? This one, right? Same thing. This to that power has to equal that. So the appropriate exponential version, 3 to the 2 is equal to 9. No duh. right? So if you do take 3 squared, right, that's 3 times 3, that's 9. Great. Okay, moving on. So now that we know how we can go from the logarithmic to the exponential, sorry, yeah, the logarithmic to the exponential version, right? We're going to do the reverse now. Grab the exponential and turn it into the logarithmic. Okay, so if you guys remember, I'm going to rewrite it over here just so that you guys can see what I'm doing, right? A to the b is equal to c, right? Log base a of c is equal to b, right? Okay, this is our boomstick, right? This is our boomstick. Okay, so then in this case, I have the left-hand side. I want to turn it into the right-hand side. Yeah, so the equivalent for this one would be log base 2 of 8 is equal to 3. So the other way that people tend to remember this is that the logarithm gives you back the exponent given a certain base, right? Okay, next one. Log base 5 of 25 is equal to 2. So we can do the same motion, right? This to that power is equal to that, right? This to that power is equal to that. Okay, last one. Log base 10 of 1 over 10,000 is equal to negative 4. Okay, this to that power is equal to that. Okay, some quick checks there for us to practice. Okay, evaluating logarithms with and without calculators. There's not going to be anything, how do I put this? Logarithms for sure are going to be done by, come on, there we go. Logarithms are going to be done for sure by calculator, nearly always, okay? Unless you know as much math as I do, there is no way to compute a logarithm by hand, okay? So just throwing it out there for you, okay? So, how to solve these, okay? So I've got these 3 things, right? Okay, I'm going to go ahead and show everybody how to do it on Desmos, because that's the easiest, I think, that everybody can use. And I'm going to let you guys use it on the exam too. So I think the best option is through Desmos. Okay, so for example, this first one, log base 4 of 64. Okay. Okay, so actually, does it say? Oh, it says without using the calculator. Okay, that's cool. Change it into the exponent version, right? So 4 to the y is equal to 64. Okay, this to that power has to be equal to that. Got it? Okay, so 4 times 4 is 16, times another 4 is 64. So that means my y is equal to 3. Okay, next one. I'm going to show you guys how to do this by calculator anyway, but let me do it without using the calculator first. Okay, so 121, 121 to the y power is equal to 11. Okay, if you guys remember, right, the square root of 121 is equal to 11. And the square root we can rewrite as 121 to the 1 half. So that means y has to be equal to 1 half. We're getting somewhere. We're getting somewhere. Last one. 3 to the y is equal to 1 over 27. If you guys recall, 27 is 3 cubed. Okay, and the way that we can rewrite this using our exponent rules is 3 to the negative 3. So that means y is equal to negative 3. Okay. Now, let me show you how to do them by calculators. I went too far, too fast. Okay. So let's go ahead and start with the first one. And I'm going to do decimals, like I said, right? Okay. If you guys recall, there's a little keyboard thing at the bottom here, right? That's got all the goodies. I'm going to go to functions, and I believe logarithms are way at the bottom. Where is it at? You might need to search for it a little bit. Where are they? There they go. Okay, so I want this log base A because this one's the one that's going to see what happened there. It gave me the little, it gave me for the subscript, right? So I'm going to go ahead and hit 4, and then in the parentheses is going to be my 64, and look what happened. Yeah. Next one, same thing. So function, where are you, logarithm? Where are you? There we go. Log of 121 of 11.5, half. Yeah. Last one, function log, uh-oh, wrong log. Function, scroll down, where's log? Where is it? I saw it. There we go. Log base A of 3 of 1 divided by 27, negative 3. Bam. All right. Okay. So Desmos can do these things for you. Okay. You just need to know how to plug them in. All right. There are 2 logarithms that are very important. Okay. These are the ones that happen so much that they get special treatment. Okay. The first one is what we call the common log. Okay. That is equivalent to this. Okay. So basically what we're saying is this, that basically the number that's right here is supposed to be a 10. There's supposed to be a 10 there, right? But we don't write it. Whenever you don't see log with a little number below, right? So whenever you see this, just that, you can assume that the number that is right there is a 10. If it's anything else, we will write it. Okay, if I'm looking for a base 4, I will write log base 4. If I'm looking for log base 12, I will put down log base 12. Okay? It's only log base 10 that has the 10 implicitly there. We don't write it, right? And we all know that it's a 10 there, and we move on. Got it? Okay. The next one is the natural log. That one is the one that's ln, okay? And that is equivalent to this right here. So basically saying that in this case, we can automatically, same idea as the log base 10, right? We can assume this is the log base e. So automatically we can assume that or log base e of x. So automatically we know that that's an e. Okay, and it's got the same treatment as the log base 10 of x. If we see ln, we know that that is going to be a base e. Got it? Okay. All right. So now, how to do these without using a calculator? Again, I'm going to do these. I can assume that that's a 10. So then 10 to the y is equal to 1,000, right? If you think it through, right, 10 times 10 is 100, times another 10 is 1,000. So y has to be equal to 3. I can assume that that's a 10. 10 to the y is equal to 1, 2, 3, 4, 5, 6 to the million, right? So 10 to the y is equal to 1 million. Okay? If you multiply 10 by itself multiple times, the number that you're going to look for is 6. So 10 to the 6 is a million. Okay? Let me highlight my answers here. Bam, bam. And the last thing that I got to cover is just how to find these sort of just using your calculator, right? So let me erase these. If you just type in log, you don't have to go through the functions. You can just type in log. It'll understand what you're trying to do. 327. We've got what we wanted. This is, well, this is equal to 2.5145 and change. Yeah? So then this is basically saying, right, that 10 to the 2.5145 and change is going to be equal to 327. Done. Got it? Okay. And then the last one, finding ln. Okay. Same thing. I can go ahead and type in ln. ln of 500. Okay. So then this is equivalent to saying, right, my y has to be equal to 6.21461 and change, right? So basically saying e to the 6.21461 and change is going to be equal to 500. Whoa, I highlighted the wrong thing. There we go. And I don't think I highlighted anything on my previous one, did I? Yep, I did not. Okay, that's it. This is more or less just getting comfortable with how to go from logarithmic to exponential, exponential to logarithmic, and then how to use the calculator to find these numbers. Okay, like I said in the previously, right? More often than not, you will be using your calculator to find all of these logarithms. Okay, so just have it handy. You can use it on your phone, you can use it on your tablets, wherever. Okay. Besides that, I think that is it. Lecture questions come up next. If there's any questions on the stuff, as you know, as you guys can remember, we'll try this stuff out in class. This is going to be a really quick section. Besides that, happy studying.